This is gas stoichiometry part 2. So our prompt says gaseous sulfur dioxide reacts with oxygen gas to form sulfur trioxide according to the following chemical equation. So if 7.85 liters of SO2 at 30 degrees Celsius and 1.15 atm. So let me color code that information for SO2 is combined with 3.25 of oxygen gas at 25 degrees Celsius and 0.985 atm, what mass of SO3 will be produced, assuming if the reaction goes to completion, and which is the limiting reactant and which is the excess reactant. So given the following information of each of the gases, what we're going to find first is the N value, because that's a known. So what I'm going to do is I'm going to set sulfur SO2 and then O2. Okay, so we know that we can use the equation PV equals nRT, ideal gas law, and we're going to isolate to solve for N. So N equals PV over RT. So we're going to do some plug and chug substitution. So we're going to have, for SO2, we're going to do N equals P is 1.15 atm multiplied by the volume, so 7.85 liters, over the R value, which we're going to use 0.0821 L atm over moles of mole K, because we're dealing with ATM, so that is our R value to use. And then 30 plus 273 is 303 Kelvin, so that's our T. And then our N gets us 0.363 mole of SO2. Then same thing for oxygen, N equals 0.985 atm times 3.25 liters, and then R value and then times 298 Kelvin, because 25 degrees plus 273 gets us 298 Kelvin. And if you do the operation, you should get 0.131 moles of O2. Now, this will not find us our limiting reactant or the excess reactant, because according to the balanced equation, there is 2 moles here of SO2. So what we're going to do is that we're going to have to determine the moles of O2 needed to react with all of SO2. So how we're going to do this is we're going to take this number here, and then we're going to have to multiply by the chemical the coefficients in the balanced chemical equation. So that's going to be 2 mole of SO2 and then 1 mole of O2 on the top to get 0.181 mole of O2. So now that we see which number is greater, which is going to get us, for O2, it is a limiting reactant. And then for SO2 is our excess reactant. And then now that we know that oxygen O2 is our limiting reactant, we can take that to solve for what mass of SO3 is going to be produced. Okay, I'm going to scroll down a bit. So for the second question, I'm going to use a different color. So we're going to solve for moles of grams of SO3 given our 1.131 mole of O2. We're going to multiply by the chemical coefficients. So 1 mole O2 and then 2 mole of SO3. And one more factor, 1 mole of CO3 is 80.00 grams because of molar mass of SO3. And if you do the operation on your calculator, you should get 20.96 grams or 21.0 grams of SO3, rounded to 3 significant figures. And that's it.